Hi, so this is the last linear regression, basic regression model diagnostics issue, which is to look at what's called the residuals. Um, this probably gets a little beyond this class, but a residual is the difference between the observed value from the data and the value along the regression line. So this is a nice little picture of these d values, these differences. These are the residuals. So looking at residuals is a test of model fit, and it's a test of or model lack of fit. So it's a diagnostic for the quality of your regression. Um, this is not a great example because it's just a small amount of data, but we can either generally you just plot the residuals against x. That's what this is. So it's y minus y predicted. This is the residual, those d's in the last graphic, and the x's are just simply the datas. And what you look for is a funny pattern, and if you see a funny pattern, then you might have a regression problem. The analysis of the funny pattern, though, is probably beyond this class. So like this right here, there's no funny pattern, but this one they kind of start fanning out, and so that's kind of a funny pattern. But if you just look at your residuals, at least you can do some basic diagnostic. The question, though, is, what do you do about the funny pattern? This one, your residuals are increasing over time, so it looks like things are becoming like more variable or something over the x value. But so, anyways, let's just learn to do really basic residual diagnostics in SPSS so that we can at least run them. So we have the data that I'm looking at is it's one that we use for correlation. It's murders and robberies. I don't know why I chose this. I just did. I don't think we did a regression on this yet, but let's do one. So let's do analyze and let's do regression. I'm not really interested in a regression model per se. I'm interested in looking at the residuals, but let's do linear regression. Robberies, I'll make that dependent, and we're predicting robberies based on murders. This is one that's arbitrary. You can predict robberies based on murders or murders based on robberies. But I want to do save, and I want to save two things. I want to save the unstandardized predicted, like we just did in the last video, and the unstandardized residuals. Okay. And hit go. And go. Okay. And what it's going to do is it's going to do this. Now it's fitting a regression model, but I'm not that interested in the regression model. Let's look at it. But so the R squared is 0.58. That's pretty high. The intercept is not significantly different from 0, but that doesn't matter. The slope is. So we have this would be a y equals mx plus b. It would be y equals 25 times x minus 13 model. But I'm not too interested in the model. It is a significant regression model. What I'm interested in doing is looking at the residuals. So what SPSS gave me when I checked off that unstandardized predicted and the, well, see, it gives, when you hover over, it actually gives what you're looking at in detail. And then the unstandardized residual. So what this is just the data, the first two columns. The third column is the predicted, which there's a substantial difference, by the way, between 25 and 47. The actual data was 25 and the prediction is 47. That's pretty far off. But what the residual is it's the actual data value minus the predicted. Not the other way around, although it really wouldn't matter because you're looking at the difference. So these are the residuals. It's the second column minus the third column, and then that creates the fourth column. That's why I did them all together so you can see what we're looking at. And so, what does this mean? What are these residuals doing in terms of how good the model is? Now, the model isn't all that bad. I mean, it has an R-square of 0.586. It's kind of ho-hum. It's not a great model, but it's significant, so it's not a complete, disaster of a model. The other thing we can do is a plot, and it's helpful to look at the plot because, again, we're looking for funny patterns. So I want to go back to regression, and I want to go to linear. Same thing. I just forgot to check off the plot before. And so I go to linear, and then I want to go under plots, and it already knows what I'm kind of looking for. I'm looking for a linear regression plot. X is dependent, and then Y is going to be these are actually going to be the residuals on the Y-axis. Okay. So I want to select the z-rids, don't worry about whether they're standardized or not, and then run it against the dependent variable. Okay. You could also run it against a predicted variable. You get essentially the same thing, but just run this. So dependent, it's kind of bizarre because SPSS doesn't give you the actual data in this case. It's just dependent. Okay. So dependent is always what your x value is, and then just z-res for the residuals, and then run this plot. We should probably look at a normality plot too, but let's be lazy. Let's look at these. Okay, and then continue. And what you get, and then hit OK, it's going to run the regression model again, but that's okay. So I get these plots, which are what we're looking at in the slides as well. So this plot here, the plot that I just ran is literally the same as this plot here. It's the x values against the residuals. So SPSS, if I can find the output. I ran a histogram kind of for fun. I don't really want that. They're clearly not normally distributed, but this is such a small data set that this really doesn't really matter that much in this case. So right here is the plot that this is the plot that this is. Okay. So we're looking at the residuals versus the x values, and what we're looking for is across the different values of x, do we see any funny pattern? We really don't, but again, it's such a tiny data set that, you know, with a large data set and you see this kind of huge fanning out or something, you have a regression problem. But with a small data set, there's really just, okay, this is a residual plot. I mean, I can't really see any major issues with this. So that's how to do a residual plot, just something to be familiar with because it is a major way to diagnose a regression model. The mathematics and things that you might do with this kind of go beyond the scope of this class, but just to verify that this is in fact a way to analyze your regression models and to check whether you're violating assumptions and stuff. So residual plots are good to look at, something to be familiar with.